Hey everyone, just a quick rundown on the IDEX application built for the IDEX laboratories and the animated model, and how to connect our sensors to the model and make things work for a presentation or demo. If you launch the link that I provided in the email, you'll get an application screen that looks something very similar to this. We have some initial setup that needs to be done, very simple, and then we could operate the actual model itself. If you notice to the left-hand side of the application, we receive a list of all sensors connected to our IoT platform. If your sensor does not appear in that list, please follow the instructions on how to connect your sensor to the IoT platform. We're going to connect the very same way we would connect one of our sensors to the solution experience dashboards. So my sensor does appear in this list. It's called Tom. Once I select my sensor, you notice my sensor appears down here in the gray bar. That's the sensor we're actually monitoring. To the right of that, we have sensor values that are being fed to the dashboard. Those are the four values we're going to use in our presentation. We have temperature, we have a lux light value or a voltage, we have a movement or vibration value, and we have a humidity value. What I need to do is set limits or tolerances on each one of those values, or three of them, to make the actual model work. So following the storyline, if my temperature falls below, let's say, 75 degrees, and my humidity light limit value is above 60, and my volt light limit reaches 35 or above, things will happen within the model. We'll trigger some actions in the model. Actually, I'm going to take this to, we can leave it at 75. Now, if you notice in the lower right-hand corner of the screen, we have an SMS setup, two gears that set up SMS messaging. This allows me to send a text message to a participant in the audience who wants to sort of participate in things as we move along. So I'm going to set up some rules here that says if temperature is below 75 degrees, I'm going to send a text message to this telephone number following this format, plus country code, area code, and then phone number, and then an actual text message. And then I'm going to activate my rules engine. If you don't click this activate rules engine, it will not send the text message. The orientation model could be set to the left at robot, it doesn't matter. And then I'm going to select OK. So now I have my tolerances set, my sensor has been selected, I'm reading values, let's begin the model. So if I begin the model, you see the sensor settings are being fed to the dashboard of the application itself. So I said if we go below 75 degrees, we're going to trigger an action within the model. So I'm going to just rest a cold can of pop on top of my sensor, and we're going to try to get it below 75 degrees. Once it's below 75 degrees, you notice an alert appears. I click that alert, and it takes me to the temperature readings within the barn itself. We have two maps. We have a sensor location barn map, and we have a trouble location map. The sensor location is a map of all of our sensors connected to the system itself. The trouble location map is our specific sensor that has given us issue. Now I could navigate through this sensor location sensor map and select different sensors if I wanted to, or see all the various locations of the sensors that are connected to our system itself. If I go to the trouble location, I can do things like zoom in on the exact location of the sensor, so I know exactly where our issue is happening, and then zoom back out to go to the higher level view of the actual sensor itself. We also have our temperature and our humidity readings being fed to the dashboard. Lower right hand corner, we have historic values over time for the temperature that exists within the barn itself. If I drag to the right, you could see exactly when we had an issue within the barn itself. So at about 9:30, we had an issue in the barn where our temperature fell below our defined value. We have a issue report, lower left. It tells us in barn 23 we had issue on 9/3, 13, 14, and 15 with temperature that also fell below the value. We have a dummy button that allows me to select that button and tell a story around how we would generate a work order. feed information to predictive analysis for further analysis, and so on. Now, if I go back to the map, we can start meeting some of the other criteria within our dashboard itself. Now I want the humidity value to go above 60, and the humidity alert appears on the water tank here itself. So if I take my sensor and blow on it, you notice that our humidity value or alert appears above the tank, and a leak starts to happen within the tank itself. If I select that, it takes me to a screen that shows me what the issue is within that tank. It allows me to zoom in on the tank so I can see exactly where the issue exists. It gives me the humidity value of the tank itself. So if we're dripping water or leaking water, it's measuring humidity or condensation in a drip tray under the water tank itself. And it tells me I have a leaky valve that supplies water to the tank. Notice that the condensation tray is showing a level that's on the increase for condensation within the tray itself. And this chart here is a pretty important chart. It tells us the normal consumption of the water level in the tank and then the actual tank level. So you can see that our tank level is below where it should be, so we probably have a leak in the tank itself. We get a report of all the general maintenance that has been performed on the tank over time and the kind of tank that we have here. So our issue is the actual valve. We can go ahead and place an order for the valve that show the issue on the tank. Now, go back to the map, and now we have a voltage issue with one of the Snap DX analyzers. It's a device that they carry on the field that detects disease in animals and so on. So if I simply hover a flashlight or a light source above my sensor and get it above 35, remember the value we set in our first screen, it's going to take us directly to the voltage screen or the issue with the SnapDX analyzer, and tells us that our output voltage is varying between 20 and 21 volts output, and it has a 82% chance of failing over the next 30 days based upon information we gathered previous. So we have dates for maintenance reports that have occurred over time where they've checked that same voltage regulator, and it's probably time to order a new voltage regulator for the device itself or have the device replaced. Now, going back to the map and following the storyline again, we also have a barn that has a milk tank in it. Now, the milk tank reports no issues, but it's important to see some of the information within that milk tank. Simply click on the word milk above the barn, and you'll see our milk tank reports no problems. 5 tests have been performed this month, and there is no corrosion. To close the little pop-up, just click the milk tank again. Now, the last click we have within the application itself is on this brown horse. We're going to monitor some activity with the brown horse because the brown horse is going through some rehab after injury, and we need to get it back on the racetrack itself. So just click the brown horse. A screen appears that is going to monitor if the horse is meeting its rehabilitation requirements. So take your sensor and tip it back away from you, and a screen will appear that tells us that the horse is running, and it gives us the device that they actually use on the horse that monitors things like temperature, heart rate, respiratory rate, and sends that information to the phone or to the cloud. If you tip it back towards me, it tells you the horse is now trotting, and the device that actually monitors that. So we're monitoring actual GPS location and the actual movement within the horse itself. Back to the map. To close the application and show the customer the items that were involved in the solution, simply hit the X in the IDXX logo, and it takes me to an SAP HANA splash screen and the solutions that were involved in the makeup of this solution. Have any questions, feel free to give me a call. I'm going to post this out on YouTube. Feel free to use it for reference, and good luck with your demo.